Hello everyone, I'm Arnel the Log Dog, and I'll be talking about how we measure the performance of the key nearest neighbors or the KNN algorithm. So when we say performance, we mean how well KNN works in different situations. So there are three main things we look at: the accuracy, execution time, and the sensitivity to parameters, especially the number k. So first, let's talk about accuracy. So here we have the visual representation of our data, the sample data that we use in our fit simulation, which was discussed by Jairo Sechenova. So here we have the fruit, which is the two apples and the two bananas, and our unknown sample, which has its corresponding sweetness and crunchiness. We have also here the scatter plot to determine the distance between each fruits. So here, this one red is the apple, this is the unknown, and this is the banana. And here we have the table for our fruit or distance, which was calculated using the Euclidean distance formula. And here, in our fruit simulation, the KNN guessed the type of fruit by looking at the three nearest fruits in the training data. So in our fruit simulation, we use the k equals to 3, meaning it looked at the three nearest fruits in our training data. So since we use the k equals to 3, meaning it will only scan the three nearest neighbor or fruits. So it will only cover this. So in our scatter plot, it will be look like this. So since it only covers the three nearest neighbor, which is the banana, two bananas, and one apple. So since these three, the most common is the banana, meaning the unknown would be classified as a banana. So it would become a banana. So the KNN predicted it as a banana, and that prediction was correct because most of the nearby fruits were bananas. This shows that KNN can be accurate when the data is well clear and well organized. So next, let's look at the sensitivity to the value of k. So the KNN depends a lot on the value of k, or the number of neighbors it look at. So an example is we use k3. But what if we change its value to, let's say, 1 or 4? So if we change its value to 1, for example, the neighbor it was scanned will only the first or the most nearest neighbor it finds. So here, based on this our table, it will only scan the nearest neighbor, which is the banana, meaning the value of the unknown would still be a banana. So what if there's a much closer apple, for example here, since this would be an apple. So if we use the k equals 1, it will only scan the most nearest, so meaning the value of our KNN will change from banana to an apple. So the result might be different. So meaning this means the KNN is sensitive. So if the key is too small, it might follow just one neighbor, which could result to an error or an outlier. But if the key is too big, it might mix into many different kind of fruits. So we need to choose the key carefully. So now let's move on to the execution time. So with a small data set, like a list of just a few fruits, the KNN works very fast. But what if we have thousands or even millions of fruits? That make our KNN much more inefficient. So if we use, for example, here we have the scatter plot. We have with multiple different kind of value. So if we use, it will scan So if we look for the nearest neighbor here, the KNN would become much more slower because every time it makes a detection, it would compare the all the new item to every single one of each data set. So meaning if we go for example here, let's range here, it will one by one scan each data and see which of the most fruit would be the unknown data would be classified as, meaning it takes too much time, especially if the dataset are large or has many features. So the KNN works well when your dataset is small and clean, but as your data grows, it becomes messy and slows down and can also give a less reliable results. So now that we have seen how KNN performs, let's hear from Miles, who will talk more about the KNN's strengths and limitations.
Hi, I'm Miles Parandero, and I am going to talk about the strengths and limitations of KNN algorithm. The strengths of KNN are: first, it is very simple and easy to understand. KNN is one of the easiest machine learning algorithms to learn. It works like this. If you want to know something about a new data point, just look at the closest points around it and then use their answers. It's like asking your neighbors for advice. Second, no training time needed. Some algorithms need time to learn before they can make predictions, but KNN doesn't need that. It just saves the data and makes up predictions when you ask it to. This saves time and is easy to set up. Third, can be used for both classification and regression. KNN can do two kinds of tasks. One, to put things into groups, like classifying an emails as spam or not spam. Two, to guess numbers, like predicting someone's age or height. Then the last one, it can adapt easily to new data. If you get new data, you don't have to train the model again. KNN will just use the updated data when making predictions. This makes it flexible and easy to update. Well, the limitations of KNN are: it is very slow during predictions of large data sets. When you ask KNN to make a prediction, it looks at every point in a data set. If you have a lot of data, this can take a long time and be slow. Second, not good for high dimensional data. This is called the curse of dimensionality. If your data has too many things to compare, like hundreds of numbers for each item, KNN doesn't work well. The idea of nearest neighbor becomes confusing, and the predictions may be wrong. Third, performance depends on choosing the right value of key. Key is the number of neighbors KNN looks at. If key is too small, KNN may make bad guesses. If key is too big, it may be too general. That's why you need to choose the best key by trying different values. And the last one, it is sensitive to noisy or irrelevant data. If your data has mistakes, weird values, or features that don't matter, KNN might get confused and give bad results because it treats all features equally, even the ones that shouldn't be there. To solve some of these problems, we can use techniques like KD trees for faster searching and principal component analysis to reduce the numbers of dimensions. Now that we know the KNN strengths and limitations, let's compare it with other algorithms. Elishama will walk us through the comparison.
Hi, I'm Elishama Jasper Acedo, and I'll compare KNN with some other common machine learning algorithm. KNN is slower than most algorithms when making predictions, but it's easy to understand and doesn't need any training before use. And let's look at how KNN compares with others. The K-nearest neighbor is very easy to understand. It doesn't need training, so it's fast to set up. But When it makes prediction, it can be slow, especially with large data. It gives good result and is very clear to explain. Random forest is more accurate than KNN in many cases, but it takes longer to train and it's more complicated to understand and to explain. Naive Bayes is fast in both training and prediction. It's not always very accurate, but it's simply and easy to understand. Logistic regression is also fast and works well with data that has clear line between classes. It is also easy to explain. Now in conclusion, if you have or you want something simple and easy to understand and your dataset isn't too long or too big, KNN is a great choice for you.
Thank you so much for watching our video. We hope this helped you better understand the KNN algorithm and how you can use it. Keep learning, keep exploring, and see you next time.